Okay, guys, we're going to use this unit for both chemistry and physics just because it goes hand in hand. I've been saving it for a rainy day when we need some easy lessons. So here it is. So gas laws. So the first thing we're going to talk about when we talk about gas laws is something called the kinetic molecular theory. And it has three parts to it. The first part says that all matter is composed of atoms. Now, we know that atoms are made of protons, neutrons, and electrons, and we've already talked about that throughout the whole entire year. Second part, particles are always in constant motion. So when we talk about particles are always in constant motion, we're talking about the fact that even though we have a solid, the particles are so tightly packed together that they're still vibrating with one another. And say we have a liquid, well, they're a little more spread out, but they're still moving. And gas particles are completely in random motion. They're flying throughout the room and they're always bouncing off of one another. So the third part. Now physics, we've talked about this before. All collisions are perfectly elastic. They're perfectly elastic. Okay, so what does this mean? This means that the energy that you start with is the same energy you begin with, okay? And that goes back to the law of conservation of momentum. If you want to think about the word elastic, means bounce off each other. Something that's elastic, like an elastic string, is stretchy. Okay, the next thing, a little vocab word you're going to hear is something called a mean-free path. Okay, the word mean for math means average. Okay, so if we're talking about the mean value theorem, it's the average rate of change. Okay, so from 7th grade math, mean means the average. So a mean-free path is the average distance a molecule travels before colliding with another one. Okay. So I thought we would talk about a few different things before we get into actual gas law questions. So you're going to have something called standard temperature and pressure. Okay, also known as STP. So if you see that, it's STP. So standard temperature and pressure is 1 atmosphere, 1 ATM, and we're at 0 degrees Celsius or 273 Kelvin. Now, gas law problems, it's super important that you are always in Kelvin whenever you do your calculations. And we're going to go through how to do that in just a second. One other thing for chemistry you're going to need to know, and we'll go ahead and do it for physics also. 1 mole of gas at STP occupies 22.4 liters of volume. So what we're going to do for the next few minutes is we're going to review how to do some conversions. Okay. Now, pressure. Let's talk about pressure. If we're talking about in terms of physics, pressure is something called force over area. Okay, it's force per unit area. So, say a girl steps on your foot with a high heel stiletto heel. It hurts, right? It's because you're exerting a force over super small surface area of the heel. Now, if someone steps on your foot with, say, a pair of Crocs, it's not going to hurt that much because all that force is distributed over their whole foot. Say I was to step on a nail, just a single nail that's sticking out of a board. Well, that's going to really hurt. But if I lay on a bed of nails, it doesn't hurt because my force that my body exerts is over a large surface area. So keep that in mind. Now, units for this. We're going to say 1 atmosphere is equal to 101.3 kPas, kilopascals, that's what that stands for, is equal to 1.01 times 10 to the 5th pascals, is equal to 760 millimeters of mercury. These are just conversion factors, different units, is equal to 760 torr, which is also equal to 14.7 psi. And psi stands for pounds per square inch. Okay, so I just want to go through a couple examples doing some conversions with pressure. Most of the time in these sorts of questions, if we're in physics and we're talking about pressure, we're going to be in pascals. But for these types of questions, we're going to be in atmospheres. So you have to kind of be able to go back and forth. So let's take this example. Convert 1080 millimeters of mercury, and I want to go to atmospheres. Sorry, I keep hitting my arm of my recording arm. Okay, so this is just a dimensional analysis question. So we're going to do 1080 millimeters of mercury over 1. Now, the conversion factor says that we're going to have 760 millimeters of mercury to 1 atmosphere. So we're going to do 760 millimeters of mercury, and our units should cancel diagonally like we did before in the year. So we're just going to divide those two numbers, and I should get 1.421 ATM. Now, what is an ATM or an atmosphere? An atmosphere is the pressure that we feel from the atmosphere currently. So like we live in 1 atmosphere of pressure, depending on where we are on the earth, but pretty much it's 1 atmosphere. Let's do one more example of a pressure conversion. Let's do 300,000 kPa, and I want to go to psi, pounds per square inch. Okay, so we're going to start with our given. We're going to write it over 1. Now we're going to say that there's 101.3 kPas to 14.7 psi. We're going to multiply the numbers across the top and divide by the bottom. And we should get 43534.057 psi. Now remember, you messed up if your units don't cancel diagonally. See, these cancel, millimeters of mercury cancel, millimeters of mercury cancel, you're left with ATMs, and on this one you're left with psi. So just keep that in mind. We've done this before, so we should be good. Now let's talk about temperature conversions. So just reviewing temperature formulas. Okay, so your formulas. Degrees Fahrenheit is equal to 1.8 degrees Celsius plus 32. We have degrees Celsius is equal to degrees Fahrenheit minus 32, all over 1.8. And Kelvin is equal to degrees Celsius plus 273. Now remember, we don't write Kelvin with a degree sign. They dropped that about 60 years ago. Okay, just trying to see if there's anything else I need to talk about. Okay, we should be good. So let's do a couple examples with temperature conversions. So let's convert 75 degrees Fahrenheit, and I want to go to Kelvin in degrees Celsius. So in order to get to Kelvin, you have to be in degrees Celsius first. So we're going to go there first. So degrees Celsius is degrees Fahrenheit minus 32 all over 1.8. So degrees Celsius is 75 minus 32 divided by 1.8. Put that in the calculator. You should get 23.89, that's fine. Like that. And to go to Kelvin, it's degrees Celsius plus 273. So we're going to do 23.89 plus 273. So we get 296.88 Kelvin. Okay, so it's super important that you remember that you have to be in Kelvin whenever you're doing gas law calculations. Let's do one more. Let's convert. Let's go 400 Kelvin, and I want to go to degrees Fahrenheit. So from Kelvin, you have to go to Celsius. So Kelvin is equal to degrees Celsius plus 273. So 400 is equal to degrees Celsius plus 273. So your degrees Celsius is going to be 400 minus 273. Using some simple algebra, and you get 127. Now, if you want to add that formula up to the top of your conversion chart, degrees Celsius is Kelvin minus 273. I'm okay with that. Now, from there, we're going to plug into our degrees Fahrenheit formula. So it's 1.8 degrees Celsius plus 32. So 1.8 times 127 plus 32. And you should get 260.6 degrees Fahrenheit. So our lesson that we're going to do for homework and our practice problems are going to just be pressure conversions and temperature conversions for today. And I will have another video out shortly. Hopefully you'll have a good evening.